Hey everyone, and welcome back. Today we're going to demystify one of the most fundamental things about your computer, its memory. We're going to find out why your computer actually has two different kinds of memory and why that's the secret behind how it works every single time you click your mouse.
So you've totally been there, right? You press the power button and it feels like it takes forever for your computer to finally boot up. But then once everything's running, you click on an app you had open a minute ago and boom, it's there instantly. What's the deal with that huge difference in speed?
Well, the answer comes down to this really simple but brilliant idea. Your computer doesn't just have one big blob of memory. No, it actually has two completely different types, and each one has its own very specific and very important job to do.
To make this super easy to get, we're going to use a simple analogy for this whole explainer. I want you to picture your computer's memory system as two things: a workbench right in front of you for all your immediate tasks, and a giant warehouse right next door for all your long-term storage.
Okay, first up, let's zoom in on that workbench. This is where all the action happens. It's the hands-on, get-it-done-now zone.
Now, the technical name for our workbench is primary memory, but I bet you've heard its much more common name, RAM, which just stands for random access memory. And that's exactly what it is, the computer's super high-speed but short-term workspace.
In this workbench idea, it fits perfectly. Just like a workbench, RAM is for the stuff you are using right this second. Everything's right there within arm's reach, so access is incredibly fast. But, and this is the big catch, when you're done for the day and you turn off the power, the workbench gets completely cleared off. In tech terms, we call this being volatile. It forgets everything as soon as the power's gone.
So, if your workbench gets wiped clean every single time you shut down, where do you keep all your tools and all your projects so they're safe? Well, for that, we need to take a little trip to the warehouse.
And this warehouse, that's what we call the computer's secondary memory. These are the parts you probably know pretty well, like an old-school hard disk drive, or one of those newer, way faster solid-state drives, an SSD. And this is where we see that core trade-off. The warehouse, your secondary memory, is absolutely massive. It can store everything: your operating system, every app you own, a decade's worth of photos. But, it's going to take a little longer to go find something in a giant warehouse than to just grab it off the bench. The most important feature, though, is that it's persistent. You can shut the power off for a year, turn it back on, and everything will still be there, safe and sound.
So what we have are these two amazing systems that are basically opposites but work together perfectly. One is built for pure speed and the other is built for pure space. It's this beautiful balance.
This table just lays it all out, side by side. Our workbench, primary memory, is all about speed. It's crazy fast, but that tech is more expensive for every gigabyte, which is why you have less of it. And of course, it's volatile. It's temporary. Then you have the warehouse, secondary memory. It's slower, yeah, but it gives you that massive capacity for a much lower price. And it's persistent. It's permanent. They're just perfectly designed to balance each other out.
But here's the thing, the real magic, the whole reason your computer feels so responsive isn't in the workbench or the warehouse alone. It's all about how they work together, like a flawless team.
So let's go all the way back to that first question. When you click an app's icon, you're basically sending a request to the warehouse where that program is stored permanently. Your computer zips over, grabs a copy of that program, and brings it over to place it on your workbench, your RAM. And now, because it's sitting on that ultra-fast workbench, you can use it instantly with zero lag. That's the aha moment. The little bit of slowness at the start is the trip to the warehouse. The instant speed you feel after that is because you're working right on the bench.
So you see, this isn't some kind of flaw or a limitation. It is an absolutely brilliant and efficient design. It's just a really elegant engineering solution that gives us the best of both worlds. You get the incredible speed you need for active tasks and the enormous storage space you need for everything else.
And seriously, you can't overstate how important this is. This whole teamwork, this architecture between primary and secondary memory, is what makes modern computing possible. It is the fundamental architecture of digital recall that powers literally everything you do on a computer.
And that just leaves us with this one really cool question to think about for the future. As our technology gets better and better, as ultra-fast SSDs start to close that speed gap, will that line between the workbench and the warehouse start to get a little blurry? What's computing going to look like when it feels like everything is instantly on the workbench all the time? Anyway, that's something to chew on. Thanks so much for hanging out for this explainer, and we'll catch you on the next one.